So right into our second paired function. This time, and I'm going to go a little faster with this one because you're going to see a lot of the stuff is repetitive. This time we're following the x value on the unit circle. And we know if we draw a little triangle of the unit circle, when I say x value, I could also be talking about the cosine of the angle. So you'll see the same angles for our input, but this time as we do cosine, we are following the x value around the unit circle. So putting on those quadrantal points, and this is a little more up to speed with how you would actually graph it if you were doing this. So I write the points out, I circle the x values, and those are the points that go in my table. So 1, 0, negative 1, 0. Our scales are going to look the same. So basically here, I'm still going on the same interval. That doesn't really impact things. When I'm graphing a basic trig function, I'm going to use these same intervals no matter what type of total interval they told me. I'm going to use this scale. That the interval really just tells me how far over to put my y-axis. So from here, if I graph those points, this is just a 1 and a negative 1. I have a 1, 0, negative 1, 0, and a 1. And you'll see that same type of bend because if I think of my little chart, the cosine of pi over 6 is radical 3 over 2, which on the other page we learned is 0.9. This is radical 2 over 2, which was 0.7. 1/2 is 0.5, and this is a 0. So as I go between those two values, in the middle, I'm still up at 0.7. Here I'm up at 0.9 and a 0.5. So with cosine, we get a similar type of bend that continues through the graph. If I'm going to continue it out to 3 pi, and it is fine to leave this number blank. I know on the other side I wrote 5 pi over 2. We continue the curve with those coterminal angles, and then going back to negative pi, we would also continue the curve this way. So we're going to answer the same exact questions about the graph of cosine. So this is the graph of cosine. It should look super similar to sine. And if you think about the unit circle and a circle in general, the x's and y's are kind of doing the same thing as we go around the circle, especially since it's centered at the origin. It's just they're kind of at a different starting spot. So y-intercept is 1 instead of 0. So this is a change. The max is a 1, the min is a negative 1 for y. My midline is still the same thing. My amplitude, how tall it is from the middle to the top, is still the same thing. And even though we start at a different spot, the period of the graph, the time it takes to repeat a cycle, and then we start again with that cycle again, is still 2 pi. Now looking at cosine, cosine doesn't have that rotational symmetry about the origin, but it does have symmetry over the y-axis, right? If I folded or reflected that graph over the y-axis, it would be the same on both sides. So cosine is an even function for that reason. And going along with what we learned way back in Unit 5, and then also what we learned in 10a, we learned that the cosine of a negative angle was the same exact thing as the cosine of the positive angle. And that's where, because of like the quadrant 1 and 4 being the same for cosine, as well as 2 and 3. And this goes along with that function rule. We kind of wrote it in the other direction, but we wrote f of x equals f of negative x, right? And that would make an even function. So if I just flip those around, we see that that is true of cosine.